Hello friends, today we discuss synthesis of heterocyclic compounds containing two heteroatom. So it's a chapter of paper 502, unit 3, organic chemistry. In this chapter we will discuss following point like introduction and synthesis of several heterocyclic compounds. So friends, you can observe that over here first four written in a blue color and also the structure of first four in a blue color, and also you can observe suffix of first four heterocyclic compound. So you observe that the suffix of first four compound is azole, and first four compound, the structure of first four compound, you can see that over here 5-member heterocyclic compound. So it's a small classification. First four is 5-member, remaining 5 is 6-member heterocyclic. Remaining 5, pyrimidine, pyridazine, oxazine, thiazine, dioxane. So also you can observe that the suffix of 5 to 9 is n, exceptional case n, pyrimidine, pyridazine in. So we can say that if suffix of heterocyclic compound, the name of heterocyclic compound is in, it means 6-member, and suffix of heterocyclic compound as well, it's 5-member. And also that's a rule of IUPAC nomenclature. Now introduction. So first we have to understand what is heterocyclic compound. Before we understand heterocyclic compound, we have to learn about homocyclic compound. So there is a difference between homocyclic and heterocyclic compound. So what is homocyclic compound? Homocyclic compound is nothing but cyclic compound having as a ring member atoms of same elements only. So it means same elements. For example, benzene. So the structure of benzene you know very well. All elements is same carbon. So benzene is a homocyclic compound. Now we discuss heterocyclic compound. So cycle you know very well, but the new word is hetero. Hetero is a Greek word. Meaning of hetero is different, other. So it's indicate itself heterocyclic compound. So cyclic compound having is as a ring member atom at least two different atom, at least one or two different atom. So friends, in our chapter we discuss pyrazole to dioxane, so with two different atoms. So there are many naturally occurring purine including nucleoside adenine and guanidine in DNA. So friend, it's a very important chapter for us because heterocyclic compound, particularly purine, used in adenine or guanine in DNA or RNA. So DNA and RNA, importance of DNA and RNA in our body, you know very well. In another word, we can say that 5 or 6 member compound, generally 5 or 6 member compound that have stable heterocyclic with aromatic property are called heterocyclic compound. So it's a simple definition: heterocyclic, one or two different atom in cycle, which is known as heterocyclic compound. We say in another word. So friends, look at over here the figure. Heterocyclic contain one or more heteroatom in a ring. So here carbocycle means benzene, cyclohexane, cyclopropane, all are cyclopropane, or we can say that homocyclic, all atoms of cycle is same. Now we talk about heterocyclic with one heteroatom. For example, pyridine, heterocycle with two heteroatom. So all compound we studied or we synthesis in our chapter pyrazole to 1,4-dioxane, or which is heterocyclic with 2 heteroatom. Now heterocyclic with 3 heteroatoms. So 1,2,4-triazole is the example of 3 heteroatoms. And generally heterocyclic XYZ means generally we can use oxygen, nitrogen and sulfur. Heterocyclic compound are another definition, another word. Heterocyclic compound are cyclic compound with at least one or more different atom in a ring. And largest part of heterocyclic compound contain heteroatom like oxygen, nitrogen, sulfur. So friends, I hope you can understand properly what is heterocyclic compounds. Now, importance of heterocyclic compound in daily lives. So, friends, look at over here the figure. You know very well. Nitrogen containing heterocyclic are rich in nature and have great importance to life because their structural unit exists in number of natural products. You know very well purines, pyrimidines, all are nitrogen containing heterocycle. They have high significance in our system. They also, you know very well, heterocyclic compounds have wide range of application in agrochemical, pharmaceutical, veterinary product, particularly agrochemical. So in fertilizer, pharmaceutical, active pharmaceutical ingredient, most of heterocyclic used in pharmaceutical or as a API. They are also used in starting material in synthesis of organic compound. You know very well starting material, like we think about Biginelli reaction. So Biginelli reaction is the favorable example of heterocyclic compound. You learn about this. There are also used in sanitizer, developer, corrosion inhibitor. So particularly pyrazone, pyrimidine and such type of compound used as a sanitizer and developer. Next one, heterocyclic compound widely found in nature. For example, pyrimidine, purine are parts of DNA, vitamin and enzymes. So there's a structure of DNA. Now 9 heterocyclic compound. First 4 5-member heterocyclic compound. So just remember that. Look at over here, friends. First one structure of one is pyrazole. So the two heteroatom, two nitrogen at adjacent position in 5-member heterocycle in one is pyrazole, and 1 and 3 position nitrogen in imidazole 5-member heterocycle. 1 and 2 position, 1 position nitrogen and 2 position oxygen, which is known as isoxazole. 1 and 3 position, 1 position nitrogen and 3 position sulfur, so thiazole. So friends, my suggestion is please refer IUPAC nomenclature of heterocyclic compound. I also share link of nomenclature of heterocyclic compound, and we will discuss in next PPT nomenclature. So you can easily understand pyrazole or all suffix like azole in. Next one, 6-member heterocyclic compound, pyrimidine, pyridazine, morpholine, thiomorpholine. So morpholine is a specific name. The IUPAC name is oxazine, and thiomorpholine is also specific name. The IUPAC name is thiazine and 1,4-dioxane. So friends, pyrimidine 1 2 position adjacent sorry friends, pyridazine 1 and 2 position nitrogen adjacent position, which is known as pyridazine. 1 and 3 position, 1 and 3 position containing in heterocyclic nitrogen, which is known as pyrimidine. Morpholine, thiomorpholine, all know very well. So first one, part A, preparation of 5-member heterocyclic compound. So first one, pyrazole. Structure of pyrazole you know very well. Pyrazole is an organic compound with the molecular formula C3H4N2. You can calculate molecular formula C3, 3 carbon, 4 hydrogen and 2 nitrogen. It is heterocyclic, characterized by 5-member ring of 3 carbon atom and 2 adjacent nitrogen atom. So look at over here friends, 2 adjacent nitrogen. The term pyrazole was given to this class compound by German chemist Ludwig Nohr in 1883. So pyrazole term was introduced by Nohr in 1883. Next one, pyrazole was first synthesized by Buckner. You know, Buckner is not the TV umpire, cricket umpire, cricket match umpire. Buckner is a scientist, a chemist. As decarboxylation of pyrazole 3,4,5 tricarboxylic acid in 1889. The antipyretic action of pyrazole was first discovered by Nohr in 1884, and many pyrazole derivatives have been explored for pharmaceutical, agrochemicals, and dyes. Several examples of pyrazole you know very well. Pyrazole is a weak base. The behavior of the pyrazole is a weak base. So first preparation, friends, we prepare pyrazole from pentane 2,4 dione. So friends, starting material we use acetyl acetone. Pentane 2,4 dione is a IUPAC name and acetyl acetone is a specific name. So acetyl acetone react with hydrogen hydride on removal of water molecule, we get Z for hydrazone pentane 2 on. Z, it's a notation. E and Z, you know very well, it's a notation. Z from Zusammen, like cis or trans type compound. So it's a Z. So friends, look at over here. The hydrogen molecule attack on this carbonyl carbon. Attack on this carbonyl carbon. So the hydrogen molecule H2 will remove from here and oxygen will remove for here. So removal of water molecule and this nitrogen attach with this carbon, so we get this type of molecule. After that, removal of once again water molecule or one heating, so we get substituted 3,5 dimethyl pyrazole. It's a very simple. Next one, next method, acetyl acetone react with phenyl hydrazine on removal of water molecule, so we get substituted phenyl hydrazine derivative. So it's a same here, removal of water molecule from this side and the phenyl hydrazine attached with this carbonyl carbon and we get this substituted molecule. After that, also on heating, removal of water molecule, we get 1 phenyl 3,5 dimethyl pyrazole. So it's a very simple preparation, friends, and next one we discuss in next video. Thank you, friends.